So here's what the intermediate value theorem essentially says. Let us narrow down our viewing window to be between these 2 points. What it says is this: if you were to pick any point between these points along this continuous function, if you pick any point, let's say for instance this point here, I can guarantee you one thing. The y coordinate of this point is going to be something between 1 and 4. That's what the intermediate value theorem essentially says. That if you close your curtains, so to speak, to a smaller viewing window, then any point that you could possibly live on within this window is going to have a y coordinate that is something between their y coordinates. Now let's consider a more popular application, and let me throw 2 more points onto this picture. So now I'd like to change my viewing window to be between these 2 points. So I'm going to narrow it down to this. Now notice that this is continuous, and notice that one of the points has a y coordinate that is negative, and then the other point has a y coordinate that is positive. So somewhere along the way, we cross the threshold from negative y coordinates into positive y coordinates. That means that at some point along the way, we passed through a y coordinate of 0. Precisely where did it occur? I don't know yet. I don't know specifically right now, but I do know that there is a location where the y coordinate is 0 because we went from a negative to a positive. So now let's actually apply IVT for a demonstration of this sort. So this is saying that I wanted to use IVT to show that this polynomial, which is continuous by the way, all polynomials are continuous, use IVT to show that this polynomial has a 0 between -2 and 5. So what you essentially do is this. You can tell the teacher right away that f of x is a polynomial, so f of x is continuous. You want to get that out of the way. You really should say this. Now, what you want to do is you want to evaluate the function. You want to evaluate the given function at the beginning and end point. Now, these are x values. Yes, this is an x value. This is x and this is x. So you want to evaluate the given function at both of these locations. So f of -2 is this, and f of 5 is this. So let me make a quick comment here in orange. So roughly -2, 62. So that's a point. This is your x and this is your y. So that point, that would be like -2, 62. That's somewhere in quadrant 2. What about this point? 5, -78. That is somewhere in quadrant 4. And this function, f of x, it is a polynomial which is continuous. So these points have to be connected. How they're connected, I don't really know off the top of my head, but suppose it looks something like that. We are guaranteed by IVT that at some point along the way, along this path, we cross to the x-axis. So now let's finish off this problem. And really, a problem like this, your answer is not 1 or 2 words. Your answer is a whole demonstration. So far what I have here in black is part of your answer. So let's finish this off. So here's how you finish this proof, because this really is a proof. It's a demonstration that something took place. You say, since one of the inputs was positive, and since the other input was negative, and since f of x is continuous, that's crucial. Since all this took place by IVT, the function f of x is guaranteed to have a 0 somewhere in this interval. Notice that these 2 numbers were the given beginning and end, if you will. Yes? So somewhere in this open interval, this function f of x is guaranteed to have 0 according to IVT.